All right, so I need to do a couple videos about aromatic compounds. This first one deals with naming. So we talked in class about that new structure, benzene, that we're going to base all of our names off of, or at least most of our names, right? So that was this ring that had a ring inside of it. So we know that there are three double bonds in there. We just don't know where they're at because they're moving. Those electrons are delocalized and they just basically run in a circle around that ring. Otherwise, this thing that I'm trying to name is called benzene, but I have a branch as a substituent off of it, and this is going to be an ethylbenzene because that's an ethyl branch. I don't need a 1 because I would assume the 1, just like on any ring. So this is an ethylbenzene. This other one is an isopropyl benzene. So if we see this aromatic structure, the ring within a ring, that's how we're going to name it, right? Otherwise, it does get more complicated than that because notice I skipped methyl, right? Technically, if you have a methyl on a benzene, we're going to use a completely different name. This is going to be called toluene, right? It is a methyl benzene, but you will lose points on the test. If you call it methyl benzene, you're supposed to recognize it and call it toluene. So if you see a methyl branch on a benzene, don't call it benzene, call it toluene. This other one also has a special name. There's this NH2 attached to the ring. This is actually going to be called aniline. Now, I don't think that you're going to have trouble with that one because you can't name that branch yet because you don't know what it's called. So you're automatically going to know, oh, this is one of those weird ones. This is a special one. But what you're going to have to look out for is that methyl, right? So if you have a methyl on a benzene, methylbenzene is essentially illegal in this class. You can't call it that. It's called a toluene instead, right? Otherwise, that's because toluene is a very commonly used aromatic compound because we use it as a solvent a lot of times because we can't use benzene because benzene turns out to be carcinogenic, right? So toluene, special name you need to know. Aniline, also a special name you need to know. We'll expand on this aniline later when we start talking about amines with nitrogen. But for now, you'll see anilines, you'll see toluenes. You'll also see possibly that aromatic ring as a substituent, in which case you're going to call it this phenyl, P-H-E-N-Y-L, right? Phenyl, that ending YL, means that it's a branch. So this is a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain, and this is a 4-phenyl octane. Remember, if that octane has 8 carbons in it, but the ring has 6 carbons, right? You have to understand that the 6 carbons is smaller than 8 carbons. That's the branch. Whereas if this was a 4-carbon chain, then I'd be calling it a sec-butyl benzene, right? So it's a fine line, but as soon as that chain is long enough, you actually need to name your aromatic ring as a phenyl, and that's just something you need to know. Otherwise, our next problem is I might have 2 substituents or 3, right? If you have 2 substituents on a ring, you can use special names, right? Because this chlorine and this chlorine on this ring are opposite of each other. One's on the 1 carbon, the other one's on the 4 carbon. There's a special name for that. This is a dichlorobenzene. But it's a 1,4 dichlorobenzene, which I may indicate using this P for para, right? This is a para-dichlorobenzene. Para means that those chlorines are on opposite sides of that ring, directly opposite of each other. And so that is an appropriate name. You can use that P to designate the location of these 2 chloros, but you can also call it a 1,4 dichlorobenzene, right? It's up to you, right? But if I use that P to indicate the position of those chloros on a test, you need to know what para means. So I want you to learn to use it, but if you end up calling this a 1,4 dichlorobenzene on the test, that's not technically wrong. The second example here, first problem I need to realize is that this is technically a toluene because there's a methyl here, right? So try not to make the mistake of calling this a bromomethylbenzene because it's technically a toluene. But it's a bromotoluene, and I can indicate that that bromine is off the number 3 carbon because it would have to be off the number 3 carbon because I have to use a 1 for my methyl if I call it a toluene. But otherwise, I don't even have to say 1, 3. I don't have to say that it's a 3-bromotoluene when I know that those positions are meta, right? I'm going to use an M for 1, 3 because meta means that it's in between the ortho and the para, essentially. Para means opposite, ortho means adjacent, meta is in between, right? Otherwise, M-bromotoluene would be a good name for this. The last one over here, I have to recognize this special thing again. This is an aniline. It's a fluoroaniline. Excuse me. Sometimes I struggle with this pen, but it's a fluoroaniline. And I'm going to go ahead and use the letter M again because it is still meta. It's still a 1, 3. I didn't have an example in here of a 1, 2, but obviously if I put 2 right next to each other, 2 fluoros right next to each other, this would be a O difluoro. Benzene. Again, I get to say benzene as long as that actually is a benzene, but I have to recognize when to use that toluene and aniline names. So multiple things coming into play here. Otherwise, if you have more than 2 substituents, then you're likely to have more than one situation in terms of ortho, meta, para. So you go back to numbers, right? If I happen to have this thing that has a bromine here, a chlorine here, a fluorine over here, that fluorine and chlorine are actually in meta positions to each other, but the bromine is in a para position to that fluorine, but it's also an ortho position when you consider the bromine and the chlorine. So I can't really do that kind of stuff. I just try and give it numbers, and I go with the lowest numbers possible, right? So I got to go 1, 2, 3, 4 on this one, right? If it was a toluene, I have to start the 1 on the methyl, so that actually kind of limits me, and or aniline, I have to start with the 1 on that nitrogen group. But otherwise, if it's 3 or if it's 3 or more branches, you can't do ortho, meta, para, but I'd like you to try and use ortho, meta, para otherwise when you're naming. Finally, there are technically polycyclic aromatic compounds. These ones I'm not as concerned with because I'm not really going to show these on the test, but just to show you what they are, right? This one is actually called naphthalene. And it's something that's in a mothball. So if you've ever seen one of those, right, and you used to put them in with your sweaters so that the moths don't eat them up, right? So your grandma or maybe your parents might still do that. I don't know, right? I haven't seen a mothball ever, really, personally, but I know what they are. But naphthalene is this thing. Don't need to worry about this for the test. This thing over here is called anthracene. But again, just like the toluene, the aniline, some of these tend to have just common names that are used for them, and there's no systematic way to name them. So don't worry about that, right? But I'm also not going to put these on a high school organic test, so don't worry about it too much, right? As long as you know how to name our benzenes, toluenes, and aniline derivatives, right? Plus, every once in a while, you'll have that phenyl add in, right? You should be good to go. So that's all the naming for aromatic compounds.